Okay, ladies and gentlemen, I'd like to welcome you to Wednesday, the third and final day of SREcon Europe 2016. Thank you all for a wonderful evening last night. I hope you had a great evening last night, and thank you very much for coming in to join us this morning. Without further ado, I'd like to introduce David Barroso from Fastly. He's a huge flamenco and Star Wars fan, so I imagine he's going to tell you about one or other of those topics right now.
Thank you. So, my name is David Barroso. I'm a network systems engineer at Fastly, and I'm going to be talking here about past, present, and future of network operation. It's going to be mostly a rant, so. I want to start by asking a question. Who is a network engineer here? Oh, there are a bunch of them. Is there any CCIE, GNCIE, something like that? Oh, I might have to leave by the back door then. So, I want to start with a bit of history to understand where we are and more or less why. So, I don't want to spend that much time on this slide, but I want to highlight something. The tools that we are using today for monitoring and for backing up the network were invented around 20 to 25 years ago. Like, who is using Rancid today for backing up the network? Like, no one? Ah. So, the point here is that most of the tools that we are using nowadays, they're really, really old. They weren't meant to be used at the scale that we have today in our networks. Like, netconf is the latest operations advancement, and that was done in 2006. So, between 2006 and 2015, from an operations perspective, nothing actually happened. In the meantime, in the system world, the opposite occurred. Like 2001, we started with virtualization, then 2005 was Puppet, then Linux containers, the DevOps movement, Elk stacks, Docker, Chatups, Kubernetes. So there was a huge disconnect in the way that operations evolved in the system world versus the networking world. Like, system was moving faster and faster, and the network wasn't. But why did that happen? Well, for starters, the network is a complex distributed systems. Like, the system people have been talking about gossip protocols and all that crap for a few years now. I mean, we've been using BGP for like 30 years. So it's not like the network is a simple thing to manage. Then, I can't count how many hacks I have had to do on my network because some developer did something as stupid as hard coding an IP on the code. So that has made operations for networking people even worse, because now you have this unique hack on the network that you can't automate, that you might forget three months from now and break stuff. And it's not like we've been staring at the wall. I mean, yeah, we weren't focusing on operation, but because we were focusing on other things. We were coming out with new network protocols, making sure that they were interoperable, and making devices faster to meet the bandwidth requirements of the application. And we have these super highly trained people that they know very well a particular product line, they know very well a particular command line, and they need to somehow show off. Like, of course, I mean, they spend like 6 months training 8 hours a day to be able to get that certification, so now they have to use all the weird knobs that they learned. So that makes the network even more complex, because now you have these one-offs all over the network that probably should have been fixed instead by just re-architecting something and making things simpler and just not work. Vendors. I mean, they are just after our money. So they don't really care about the network itself. They just want to sell stuff. They think that everything can be solved with yet another address family or encapsulation mechanism, that you need metrics, don't worry. I will come up with a new BGP address family so you can get metrics. Like, do you know what an API is? Maybe I can have that instead. Like that the network is slow to change. Don't worry, we will just come up with VXLAG and VHGRE, GNIF, and we will try to bypass the network instead of fixing why the network is so slow to change. Big operators. It's a bit sad that you have service providers out there that have like shitloads of money, shitloads of engineers, and they think that operating at scale means Notepad++ and parallel SSH. So, yeah. Well, enough with the rant because there is hope. So there are a few projects that came in 2015, enable and OpenConfig. The idea was of those projects is that they wanted to abstract how you manage the network, in the sense that today you have to think like, oh, if I want to deploy this, I have to do this. And this is a Juniper device, so then I have to do this other thing as well. But this is a Cisco device, so I have to do this other thing. So it's just a way of, this is what I want to do, and I don't want to think in how to get there. I just want to get there. So that's good. It's a nice step. Streaming telemetry is part of the OpenConfig project. It's a replacement for SNMP, finally, 25 years later. So the idea is that instead of keep polling the devices all the time, like, give me your interface counter, give me your interface counter, give me your interface counter. You just subscribe to this service, and as the counters keep updating, you will just receive them. Finally, someone realized that giving you root access to the Linux operating system of your network requirement was actually a competitive advantage and not only a headache. You might even get access to the ASIC via some SDK or needling, which will allow you, if you have the need, to start building your own control plane. Doesn't have to be like a replacement of BGP, but if you have this small particular need, you might be able to fix it yourself instead of having to wait 6 months for a particular feature. And DevOps for networking. It's 2016, and finally, networking people is talking about DevOps, and not as the enemy, but as something that could be done. So now I want to focus on a few use cases to see what I mean with this last part that I was talking about. I want to just show how we manage the network at Fastly, how we run code on the network, and how we try to make changes in the network in a simple and predictable way. So the way that we manage the network is we have a backend where we have a complete model of the network. So all the devices, links, peering relations, interfaces, everything is there. Like, so at any given point, I can just rebuild my network using that data. So then we use Ansible to translate data to like configuration, so we can actually apply that to the network, because I mean data is just data. You have to be able to push it somehow to the devices. So that's where Ansible comes in for us. Just translates data to configuration, and then we abstract all the operations with this super simple task. Like we have one to deploy like a POP, to drain a POP, to install a particular software in the network, to check if the POP is all right. So the idea is that the operator shouldn't care of the specifics of the task at hand. Like, I just want to know if the POP is all right. So you can just throw that command. Or I want to undrain the POP because I was doing a maintenance and it's done now. So just trigger that command. And now that those operations are abstracted and just are very simple, then we expose those operations via APIs and Chatups. The idea is that if you expose the operations via some API, then you can start connecting different things. Like you have your CI pipeline that is doing some changes somewhere, so you might trigger at the end of the pipeline a job to check if everything is all right, and if everything is all right, just keep going forward, and if something failed, just roll it back. And Chatups, well, it's just Chatups. I mean, it's just a nice way of operating the network with making sure that everybody is on the same page, like, oh yeah, something happened 3 hours ago, so just go to Slack and check what the hell happened. If someone was doing some change, or if someone fixed an issue like 3 months back, just scroll up and see what the hell he did to do the same. Running code on the network, we have this particular piece of code that, well, what it does is not really important. The idea is that we run some services on the network that talks with the host and allows us to actually turn the switches into hardware load balancers. So instead of having like hardware load balancer dedicated just for the task, we can just leverage the switches, which is great because they are super fast and you need them anyway, so that means that you get a free load balancer. But I mean, that's not important for the talk. If you tell a network engineer that you're going to run software on the network, I mean, that's the scariest thing that you can ever tell them. But it's just software. I mean, if you break the code, I mean, if the code running in the backend breaks, I mean, chances are that the service is going to break as well, right? So why is it scarier to run code on the network? I mean, it's just code. Just use the same principle that you would use to test your front end, your back end, this service, that service. Just CI pipeline. Just test the code, make sure that you do your integration test, that it runs on all the operating systems that you're running on the network, and then ship it if everything works. I mean, nothing mind-blowing here. This is a bit more interesting for network engineers, this use case. This is how our network looks like. We have like several POPs all distributed across the globe. And then we have, like, at some point, someone might decide, like, oh yeah, like, there is congestion on this part of the world, so I want to be able to reroute traffic to other part of the world, just normal traffic engineering changes. But when you have that many POPs, you don't want to go to all of the POPs and start doing changes. Instead, you're going to use this route server, or how people like to call them nowadays, BGP-based SDN controllers. So, well, it's just a route server. You just go there, do changes, and changes get propagated across the network. But this is super hard. And because if you make a mistake here, you are going to propagate the mistake all over the world. So you might be suddenly out of the internet because you made a typo or something else. So we use a CI pipeline to make sure that that doesn't happen. We keep the configuration for the route servers on GitHub. So when someone has to do a change, just push the changes to a branch, send the changes to a staging route server, test the changes. If they pass, then create a PR, approve the PR, and so on and so forth. Just what you would do with software, you can do it as well with configuration. It's very easy. So in summary, the network is late to the party, but we are trying to catch up. You should understand, as an SRE, you should understand why the network is how it is, so you can actually go there and try to help out, like, yeah, maybe we could do this here. I mean, I know Jenkins, you know this, so we can maybe combine knowledge and fix it together, because, I mean, it's not like everybody can know everything. So, and don't reinvent the wheel. Like, I mean, leverage on all the knowledge, all the experience that the DevOps and the SRE teams have been learning over the years. I mean, they know what could go wrong, so leverage on that knowledge and use their same tools. I mean, you don't need specific tools for the network. You can use Travis, Circle CI, whatever you want. And stop listening to vendors. I mean, they all have an agenda. They want to sell their products. So make sure that you are solving the problem that you have and not the problem that they want you to have. And if they don't give you root access to the device, don't buy them. They're probably lying. And the purpose of this DevOps for networking, SRE for networking, whatever for networking, is not to steal your job. I mean, it's to make your job more interesting. Like, if I can replace you with a Python script, maybe your job is not that interesting, let's be honest. So I don't know. And that's pretty much it. That was actually fast-ish. Someone has questions?
Hi, I'm Wolfgang from Google. I used to be a network engineer before I joined Google, so maybe I'm a little slightly out of date here. But I think the problem is, as you say, vendors. Because if you find a vendor that gives you root access, that's kind of cool, and you bind yourself to that vendor, but when you realize, oh, there's like more powerful hardware or switches out there that would be cheaper for me, but they're not opening their API or whatever, you're kind of trapped. But I think the real problem is that vendors never really like make up their mind together for a common API and stuff. As you said, but with SNMP, we were trapped with SNMP for years. What a horrible situation, right? Yeah, I just want to know, what do you think about vendors these days? How is the situation?
Yeah, I mean, this common API thing, I mean, that would be amazing, but I don't see that happening. I think that the best that we could do is try to push vendors to honor Netlink, because it's a well-known API. I mean, it's Linux-based, so Cumulus is the only one actually doing that. Honoring Netlink has other problems. That means that you have to synchronize the state between the kernel and then the ASIC, so there is like maybe some added latency there, but yeah, I don't know. I mean, I wish we could get like a common API, but I don't see that happening anytime soon either.
Me neither.
I wish I could, but
too bad.
One more question?
You mentioned that you model all your network equipment and how they attach to each other. How do you keep that in sync with the actual physical connections? Do they ever get out of sync?
Well, when we deploy a new link, the first step is to add the information in the backend. Like, you can't apply configuration changes on the network manually. You actually have to put the data in the backend and then trigger the task, and the task is going to configure it for you. So the backend is the actual source of truth.
Okay. Hey.
Cool. Thank you.
Thank you, David.
I just completed.